get started. Okay, so you have an assignment. It's due Friday for a change, and it is Saturday with the late day. Then I put PS10 out, and I made it due not next Thursday or next Friday, but the following Monday. So you sort of have 2 weekends between now and then. So there's a little flexibility there. It will involve creating a graphical user interface, a program with a graphical user interface. I was thinking about, I put up a way to make up missed Zybook points and realized that the way I proposed wasn't going to work very well. And so here's the new deal. You can do any challenge activity anywhere in the book, and that'll count toward your challenge activity points. And if you get more points than you need for your challenge activities, I'll apply them towards your participation activities. And the problem was that the chapters we're not covering don't have a whole lot of challenge activities. So I think this is a better way to make those up. Any questions or problems about anything before we go any further? Assignment going okay? Okay. Decide what to do first. So. Okay, here's a method. And the Java doc for it says returns the fourth root of x, and it requires x be greater than or equal to 0, otherwise it wouldn't have a fourth root. And there you can see the implementation. It returns the square root of the square root of x. So someone explain to me why this method is correct. And you can talk about whether a method is correct without running it and testing it. So, what if you had to convince someone that this was correct? What would you say? In the back.
From a mathematical point of view, the square root of a square root is fourth root is like 2 times 2 is 4.
Okay. So what he said was, from a mathematical point of view, the square root of the square root of a number is its fourth root. Okay? So very straightforward explanation. Square root of the square root is the fourth root. Okay, here's another one. Blood all over me. Is my nose bleeding? There's a factorial function. It says, the Java doc says returns n factorial, which as we know is the product of the first n integers. And it requires that n be greater than or equal to 0 again. And so the method says if n is 0, return 1, otherwise return n times f of n minus 1. So someone explained to me why that method is correct. It's another mathematical method. Yeah?
Because by definition, a factorial can be defined by, so if it's 5 factorial, it's 5 times 4, or you could say 5 times 4 times 3 times 2 times 1, or you could also see that it's 5 times 4 factorial.
Okay.
4 factorial is 4 times 3 factorial.
Okay. So to paraphrase what he said, if n is 0, we just define the answer to be 1. So clearly if n is 0, this does the right thing. If n is greater than 0, it's taking advantage of the mathematical fact that n factorial is the same thing as n times n minus 1 factorial. And we can see that in that case, when n is greater than 0, it returns the product of n and f of n minus 1, which is n minus 1 factorial. Okay? In both cases here, in this case, what did we not do? X is the fourth root of x. What assumption was he making about this program up here? Yeah? 1, which will then go and compute a f of n minus 1, we'll test n minus 1 and see if it's 0, and then it will compute f of n minus 2, and then we'll do f of n minus 3, and then we'll multiply them together somehow. We didn't go through all that crap. We just said we were willing to say, what does it do in the positive case? It returns the product of n and f of n minus 1, which the comment up there says is n minus 1 factorial. So 100% of you are willing to reason about that program by assuming that square root does what it says it does. About 5% of you are willing to reason about this program the same way. So I'm telling you, the secret to understanding recursion is being willing to look at this recursive call right here, f of n minus 1, and don't try to think what's going to happen when it's called. Just think, what's it going to return? If you pass n minus 1 to f, what you're going to get back is n minus 1 factorial, because that's what it says up there in the comment. Right? So the 95% of you that resist this, I'm not sure why. Recursion is just, this is a method call to f, just like this is a method call to square root. We always, when we're reasoning about methods, we assume that the methods we're calling will work correctly. And assuming that square root works correctly, we can argue that fourth root works correctly. And assuming that f of n minus 1 works correctly, we can conclude that f of n is going to work correctly. If you are determined to understand or think about think f of n minus 1, like suppose you're trying to figure out f of 10. If your thought process goes, okay, let's see, f of 10 calls f of 9, which calls f of 8, which calls f of 7, which calls f of 6, blah, 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 and then you're going to be lost. Don't do that. All right, do you believe me here? Do you believe that if you follow this strategy that you can determine whether your method is correct or not? Or does this somehow seem cheating? You can be honest with me. I think 90% of you think it's cheating, but no one wants to admit it. So what's cheating about it? What seems wrong here? Yeah?
I guess it's just that you're assuming that that the method will work when you technically haven't even finished writing the method.
Well, you got to finish writing it. I mean, that's finished.
Yeah, but
yeah, I said as you're writing it, you've got to assume that the recursive method calls you write are going to that you make are going to work according to the spec. All right, it seems sort of circular, right? We're saying the method is correct if the method is correct. Well, what about this one here? Could someone argue, couldn't you use the same reasoning to argue that method is correct? Let's see what happens. It takes n as a parameter, and then it returns f of n. Well, what does f of n return? N factorial. So by my reasoning, if we're willing to assume that the method calls that we make are going to work, can't you argue that method is correct? There's an inconsistency here. I can't have it both ways. I can't say this is correct just based on what f does, and then say this one is correct. What would happen if you called this method? Infinite recursion. You'd run out of memory. Because every time f got called, it pushes a stack frame on the stack, eats up a little more memory, and after a while, there's no memory left. So this is worse than an infinite loop. Well, maybe not. An infinite loop just sits there. Infinite recursion will run out of room. At least something happens. The program crashes. So where's the flaw in my reasoning? Is it just bogus to say that we can argue that's correct because f of n minus 1 behaves according to its spec? Yeah.
well, the first one has a base case that no matter what value you enter, it will eventually go to like a solid value.
So he's observing there's a base case that's eventually reached. There's no base case here. So there is a flaw in my reasoning. And here's the thing. What I'm saying that you can argue that this is correct is an overstatement. You can argue that this program here is correct as long as it terminates. Okay? And that one always terminates. This one is also correct as long as it terminates. The problem is it never terminates. So I sort of left off the as long as it terminates catch. So to argue that a recursive method is correct, yes, first thing you got to do is say, assuming it terminates, assuming it returns, argue that it's correct based on the specifications of the method you're calling. And then you have to have a separate argument that actually terminates. So what's the argument that this terminates? How do you know that no matter what n you pass to this thing, it will terminate? Yeah?
It'll always reach 0 eventually and end there.
Okay. He said it'll always reach 0. Basically, people like to think of recursion as a method that calls itself. But for recursion to terminate, when it calls itself, it needs to be with simpler parameters in some sense. So in this case, if you compute f of 6, it's going to make a recursive call for f of 5. That 5 is smaller. So every time you make a recursive call, the parameter gets smaller, and it can't get smaller indefinitely without hitting 0. Once it hits 0, then that breaks the cycle. This one, on the other hand, nothing's getting smaller. It's just you're just recurring with the exact same parameter. So that's not going to terminate. So that first form of correctness, saying, arguing something is correct as long as it returns, that's called partial correctness. Total correctness is what we think of as correctness. That's arguing that it's partially correct, plus it always returns. So when you're thinking about recursion, you want to, first of all, do that first exercise, argue that as long as the recursive calls behave according to the spec, convince yourself that the overall method will behave according to the spec. Then, separate, you've got to convince yourself that it always terminates. Okay. Let me show you look at this method right here. Okay, so there's a recursive method. It has one base case. If you pass it n equals 1, and we're going to assume up here that n is greater than 0. If you pass it an even number, it makes a recursive call. It returns h of n divided by 2. And if you pass it an odd number, that's the only other possibility, it returns h of 3 times n plus 1. Okay? This is sometimes called the Hailstone function. Question is, does it terminate? Can you argue that it always terminates? So let's think about it. What if you pass it h of 7? What does h of 7 return? Well, I mean, let me ask that. What method call does h of 7 make?
H of 22.
Right, it'll return whatever h of 22 returns. What does h of 22 call? H of 11? What does h of 11 call? 3 times 11 plus 1 is that. Then we do h of 17. And then h of 52. H of 26. H of 13. So it's called a Hailstone function because the parameter sort of hops up and down. You know, hail, when it's freezing, is popping up and down in the cloud before it falls to Earth. And you can see our parameters going 7 to 22 to 11 to 34 and so on. H of 13 goes to H of 40. And then H of 20, H of 10, H of 5. We're almost down to Earth, but that's odd, so it goes to H of 16. Now we're good. H of A, H of 4, H of 2, H of 1, which returns 1. So the whole thing will return 1. Okay? So what do you think? Do you think we could find a number for which it doesn't terminate? Yeah.
You said that they've never mathematically been able to prove that they always.
Right. So there's the Collatz conjecture. Says that this thing will always return 1. It will always terminate. It's an unproven mathematical conjecture. No one knows. So arguing that a recursive function terminates can be quite difficult sometimes, like in this case. No one has been able to argue this terminates, and no one has been able to show that it doesn't terminate. So it's not always trivial. Okay, now, I want to tell you a story about my experience helping people with the current assignment. In particular, the questions that have to do with mobiles. So what will happen is, let's say that we're implementing count. Count bobs. I think there's something like that. So it's supposed to, it's a method in the mobile class. And people will say, this is how people tend to think. They think, what is a mobile? You tell me, what is a mobile? Yeah?
It's a line that can either end in a bob or a rod.
A line that can either end in a bob or a rod? Okay. That gets it part of it. Someone else have a definition? Yeah?
It's like a tree.
Like a tree? Okay. Any other definitions? Yeah? A line that can either end in a bob or another mobile. Okay. Any other definitions? Let me tell you the definition that everyone that comes to my office is using. A mobile is a collection of rods and bobs. Okay? They think, okay, if this is a mobile, you know, okay, we got a rod and maybe there's a bob and maybe there's another mobile and it has that and then we have this and that, and so, you know, that's a mobile. It's just some collection of rods and bobs strung together. If that's the way you want to think about it, you're going to have a really hard time doing the assignment. That is not the right way to think about a mobile. What's the flaw in just saying it's a collection of rods and bobs hooked together? That's true. What's wrong with it? Yeah?
It doesn't imply that there's a structure to how they're put together.
Okay, he said it doesn't imply there's a structure to how it's put together. What it's overlooking is that structure. It's very easy to describe what a mobile is recursively. Okay? So let's just get rid of this. That's not what I didn't mean to get rid of all of it. There's an undo. How about that? What I want to do is turn on the eraser and scratch all this out here. Okay. I think there's two kinds of mobiles. What are the two kinds of mobiles? It's either a bob or what? Or a rod that consists of a left submobile and a right submobile. You don't have to worry about what's in those triangles. It may be a single bob, it may be a massive mobile. We just know that every mobile is in one of these two classes. It's either a single bob, that's the simplest mobile, or it's a rod with two mobiles hanging from its ends. Okay? We don't need to look into those triangles. So, if we want to count the bobs, there are two cases, right? So that applies in if. And there's an instance variable that will tell you whether something is a bob. And the other possibility is that it's the other kind. So if it's a bob, how many bobs are there in the mobile? One. It's easy to look at this thing right here And see, that mobile only has one bob. So if a mobile is just the bob kind, it has one bob in it. Then we get to the else case. And that's when students, they come up, they get this far, and then they say, okay, how do I find all the bobs? I've lost track of how many times I've been asked that question this week. How do I find all the bobs? And I say, no, 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 you're thinking about it wrong. What you've got to do is express the number of bobs in this mobile in terms of the number of bobs in that mobile and the number of bobs in that one. So what's the expression that connects? What is the number of bobs in terms of the number of bobs in the submobiles? Yeah?
You would call your count bobs method on the left mobile and the right mobile.
Right. What he said was we return the sum. So left is an instance variable that has a left mobile. So we'll call the count method on it. So that's recursive. So we count the bobs in the left, and we count the bobs on the right. And that's what we return. It stands to reason, doesn't it? That the number of bobs in that big circle is going to be the sum of the bobs on the left and the bobs on the right. Okay? Does this method always return? What's the argument that things are getting simpler? You've got to argue that things are, what's getting simpler here? Yeah?
By definition, both the left and the right mobiles are smaller.
Yeah. The left and the right mobiles are smaller than the whole mobile. There's less stuff in them than there were in the mobile as a whole. So eventually you're going to hit the bottom and just go be bobs. And I will stop the recursion. Okay, so I tell this to students and they go, wow, yeah, I get it. And then I say, okay, write another method. And so they'll say if is Bob, and they'll return whatever they're supposed to. And then they'll say else. And then they'll come up to me and what do they ask? Every single one is asked, how do I find all the bobs? Or how do I find all the rods or something? And what do I say? I say, no, 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 you're thinking about it wrong. Express the solution in terms of the solutions to the left and the solution for the right. So I'm here to tell you, every single method you write in that mobile class will have an if, and it'd be an if else. The if will be if is Bob, and there'll just be some simple answer to give. And then there'll be an else, and the else will have two recursive calls for the left and the right, and then some code to combine those answers into an overall answer. Okay? And if you start thinking, how do I find all the rods? How do I find all the bobs? No, 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 you're thinking about it wrong. You've got to think recursively. The mobile is defined recursively, so your code is going to be structured recursively. So it'll work really well just to, once you get, count bobs or whatever it really is called, written, just paste that into your next method and the structure is going to be the same. The if, the else, the two recursive calls. The only difference, here we add it. Other problems will call for different things to do, and we don't, we may not return one. But you definitely have those two recursive calls. Okay? So, any questions? Yeah?
Someone was saying that there's some way to do some of these methods with one return statement, but given that you always have to have an if-else, is that possible? Okay,
what I said on the assignment was each of the base cases could be written in a single return statement.
Oh, okay.
And each of the recursive cases could be written with a single return statement.
Okay.
There is what's called the ternary operator. I don't expect you to use it, but it works like this. Let's say you do this. Okay? A lot of people don't like it because it looks kind of weird. This is an expression right here. And the value expression is determined like this. This condition, this has to be a condition. The thing before the question mark is a condition. And it's either going to be true or false. If it's true, the value of that expression in the box is this thing here before the colon, 0. Otherwise, It's this thing after the colon, which would be 6 divided by n, whatever n is.
Yeah, I think I'll stick with BFLs.
Yeah. Yeah. Most people avoid it. There are times when I like to use it, but I don't think this is the appropriate place. So it's called, what is called is the ternary operator. Any other questions? Okay? All right. I realize that when I tell stories like I just told about students, amusing me by asking the same question over and over, that maybe you don't want to be the one that has stories told about you next time. So don't let, I don't name students by name, and I never tell a story about a single student. It's because lots of students have asked the same question. What I've noticed is there can be an hour-long wait down in the CADE lab for help on Thursday afternoons, and no one at all in my office. Occasionally, 1 or 2 people will drop by, sit for a while, and they got instant access to having their questions answered. And their classmates are still waiting to get their first question answered. Now, of course, it won't work for all of you to come up to my office, but if some of you can screw up the courage to come talk to the professor, you can get help a lot faster. And when I ask the students in my office, why aren't more people coming up, they say it's because I'm intimidating. So I'll try not to be intimidating. I don't mean to be intimidating.
And the benefit is you get your story told the next day.
But again, I'm not going to tell a story about one student that asked me a question. It's always, lots of students have done this, so it's no shame. Okay? Okay.
Hey, Joe.
Yeah?
What would be a good test case to write for, like, those, like...
Good test cases?
Yeah.
Okay, so as far as test cases go, I have, let me find the Eclipse right here. I have in PS9, I gave you Mobile examples, like right here. So this is, this defines 3 mobiles, 1, 2, and 3. So you can write test cases that use these, that call these methods to create mobiles and then run your methods on them. Yeah?
A few people in the class yesterday were asking about the test cases for 8. Are you going to release those?
The test cases for 8, the ones we're using for grading?
Yes.
I think I already have.
They had told me that you hadn't.
Well, yeah, that may be too. Let's see. Here's the modules. There's PS10, PS9. Yeah, PS8 solution. That has the grading. So right there.
Doesn't look like it's released yet.
Well, that actually means it's been released. So it's hidden, available with a link. If it's not available, let me know. We'll do that. It's available. I think the link should work for you. Okay. So we were talking last time about graphical user interfaces, and we're going to continue talking today. And we wrote a very simple tip calculator. Let me go find it. Somewhere up here. This was our tip calculator, and there it is. And what was the problem with our tip calculator? 2 major problems with it. One problem. Yeah?
The buttons and labels aren't aligned properly?
Yeah, it's not very well formatted, so it's not laid out very well. If you make it bigger, it looks like that. If you make it smaller, it doesn't look too good either. Yeah?
It doesn't do anything?
It doesn't do anything when you enter numbers and click the button. All right, so two big drawbacks here. So what we saw last time is how to get stuff into the GUI, but it doesn't look very good. So in the lab yesterday, learned a little bit about how to make, how to do layouts. So I just want to review slightly some of the things we talked about. So whenever you create a panel, so a J panel is a component of a GUI that can contain other things. And when you create a J panel and start putting things in it, every J panel has a layout manager. And that layout manager determines how things are arranged on that panel. Now you don't have to use a layout manager. You could have a J panel without a layout manager, and every time something is added, you could say add it, 5 pixels down and 5 pixels over, put it there, and make it yay big. And just tell precisely where to place each thing. So besides being a pain to do that, what's the problem with giving absolute coordinates where everything is placed? And absolutely determining how big everything is. Yeah?
It's really hard to move things around.
You said it's hard to move things around. Okay? What about from the user standpoint? Yeah?
Would it be an issue if you resize the window?
Right. The problem is when you resize the window, you expect the GUI to resize itself. It'd be kind of weird if you had like a browser window open and you made it bigger and it still used the same amount of space for the browser. You expect it to expand to fill the window. So layout managers are designed, first of all, to take some of the burden off you in doing that. But second of all, to do something reasonable as the window gets bigger and smaller. So the simplest kind of layout, the kind you get by default, is a flow layout. And a flow layout wants to arrange everything left to right. And if the window is too narrow, it makes multiple lines. So it's not good for a lot of things. If you want to have, but if you have a panel that's going to contain 3 buttons and you want them left to right, flow layout's perfect. So that's one option. And when you create a flow layout, you can make it so that everything is crammed to the left or crammed to the right or centered. So flow layout we use quite a bit. Okay? There's also a box layout. And a box layout can do what a flow layout does and arrange things left to right, but typically we use it to lay them out top to bottom. So that's an example of how to use a box layout. And you can see the same buttons are arranged top to bottom that were arranged left to right in the other one. Then there's a grid layout, which is really easy to understand. You say, I want a 3 by 2 grid, 3 rows, 2 columns. You give it 6 things. It just puts 1 in each column, and 1 in each spot. So like if you're making a calculator keyboard, grid layout would be natural. The GUI for Connect 4 uses a grid layout to lay out the bulk of the board. And then another common layout is a border layout. And it's a little hard to understand at first, but the idea behind a border layout is as you add things to the panel, you can add them to the north, the west, the east, the south, or to the center. And the things you add around the edges get whatever space they need. The thing in the center gets the rest of the space, which means that if you increase the size of the window, the borders stay the same, and the thing in the middle grows to fill that space. Yeah?
Is that like how websites made basically?
Is that like what?
Like a way to think about that, like how a website would be?
Like a web browser, yeah. So think about a web browser, or even this, this Google Slides thing. It has stuff around the edges, but it's this center portion here that gets the, when I resize it, it grows and shrinks to fill the available space. So this probably isn't written in Java, but it's behaving, the manager is behaving like a border layout. So I make it smaller. It's that guy in the middle that's adjusting. Everything else stays the same. So you're going to have an assignment where you're going to create a little game called Lights Out, which is going to have a 5 by 5 grid and some buttons. So at the top level, you're going to want a border layout. And sort of the buttons will go around the edges somewhere, and the bulk will be in the center, where there will be a grid of lights. So you use layout managers to make things look attractive. You can spend a lot of time trying to make things ultra attractive. What I care is that it be reasonably attractive and primarily functional. So let's go back to our tip calculator, how could we, we're using a flow layout manager right now. How could we do better? Yeah?
Use a box layout and organize it top to bottom.
Okay, we could use a box layout and try to, and just put all these things top to bottom. That's his suggestion. So I went ahead and wrote the code before class. So that's V1, that's from last time. Now let's look at V2. Okay, so let's look at how it's written. Okay, so, it's the same to here. It creates a J-frame and sets a few preferences. That's all the same. It creates a J panel, which is the root panel, and it sets its layout. So this is new. It sets its layout to be a box layout. And that's just what you have to write to turn it into a box layout. This parameter here, page axis, is what makes it top to bottom. There's another constant, which I can't remember, that would make it left to right. And let's see what I'm doing. All I'm doing is I create, what's happening here? This is new. So I'm creating a panel, and then I'm creating a label and a text field and adding them both to the panel. So what's the effect of that going to be? Yeah?
There's going to be like a separate section inside of the window that has another label.
Right, and this is a very common thing you do, is you don't stick everything onto one panel. You think of it, okay, here's a panel that's going to have something. You create subpanels and add them onto it. And so what I've done here is I'm creating a panel that's using a flow layout. And so it has a label to the left and then the text field to the right. So the idea is we have label text field. Then we have another label text field. So we've got one panel, two panels, a place for the total, another panel, and then we add them all to the root panel. So we add the amount panel, the tip panel, the calculate button, and then the total panel, top to bottom. So how should this look when I run it? What does it look like? We added 1, 2, 3, 4 things to the root panel, to the box layout. Yeah?
Because you haven't given whether you're going to be specifically in the panel or you're going to be specifically.
Okay, well, yeah, it can be hard to visualize. And we're using a combination of box and flows, and that's what it looks like. And I make it a little bit bigger to make more sense. So it's laid out from top to bottom. Why is check amount and this box here on the same line? Why don't, if it's a box layout, why don't we go top to bottom? Yeah?
Because those two items were defined in their own J panel, which you're adding on its
Right.
own.
We added this label and this box to a J panel using a flow layout, and then added that panel to the root. So what we're seeing is we have 3 panels each. The 3 panels each contain a label and a text field. Check amount, tip percentage, and total. So they're going to appear left or right if the thing is wide enough. And then the button is by itself. And those 4 things were then added to the root panel. So the 4 things are top to bottom, but within themselves, they're laid out left to right. So no matter how big I make this, they'll still be, they sort of try to stay centered. Obviously, it's kind of ugly, but I'm not sure why calculate total is doing what the button is doing what it's doing. But if I get it too narrow, then the flow layout breaks down. We end up with the check amount being above. Okay? So, I might say good enough. Or if I had a lot of energy, I might make it look more like this. So let's run this and see. Okay, so I got the tip calculator. So now I decide to put the total right above. And now, basically I can resize it and nothing much happens. So what layout do you think I'm using here? Yeah?
You're using like an initial top to bottom layout, and all the individual panels are also using top to bottom.
Okay. Well, actually, so he said I'm using the top to bottom, the box layout, and I am. And he said that the individual panels are arranged the same way. Actually, I got rid of the individual panels, and I just put 1, 2, 3, 4, 5, 6, 7 things, top to bottom in the panel. But where do these gaps come from? So let's look at the code real quick. I mean, this is not endlessly fascinating stuff. It's just utilitarian. But you have to know a little bit. So I create the, what I call the control panel here. So I create the label, the amount, the label, the tip, the button, the label, the total, and I just add them all to the control panel. But notice there are these special little calls you can make. So I add 50 pixels worth of vertical space. Then I add the amount level. I make the amount size as wide as it can be. I put 25 pixels more space. And down at the bottom, I create vertical glue. And basically, I say all the extra space goes at the bottom. So if you're willing to learn about these layout managers and fool around, you can make things look better. But I don't expect you all to become experts on layout managers. I just want you to understand that they're there, and you can use them to do some interesting things. But I can't say it's a fundamental concept in computer science.
I'm not sure why the contents in the panel don't move when you resize the window.
No, I don't have a good answer for you. I'm sure I could have set it up so that as we increase the size, the text box becomes bigger. But for whatever reason, that's just not how it's behaving. Okay? I'm hardly an expert on this. All right, so that's the appearance part. So it's easy enough to get the stuff on there. And if you spend a little bit of time, it's not that hard to make it look reasonable. So the next question is, how do you make it do something? Right? That's the key. And when we look at that, there's something else to learn about inheritance and interfaces and polymorphism in general. So let's take a break and we'll see how to make this thing actually perform. All right, I got a question at the break. I'm glad I did because I wanted to say something about it. When you're working with this week's assignment, I gave you a zip file that contains a little file system that's used in the examples. And you have to unzip it. And if you unzip it the wrong way, what you end up with is an extra layer, and then it looks like all my methods are off by a little bit when you run them. So I don't know if you can see up here, that under demo, there are 4 folders: folder 1, folder 2, folder 3, folder 4, and document1.txt. If you unzip it the wrong way, so let me do that. So I'm going to call this demo X. Oops. Okay.
You have to unlock somewhere.
I have what?
Your Windows keys being held down from
I'll give it one more try here. Okay. So now what you can do is just double click on demo.zip, and it offers to extract it. And so I'm going to go to extract and say extract all. And it wants to extract it to a folder called demo because the file itself is called demo.zip. So what you got to do is just delete the demo part. If you leave it in, so I'm going to leave it in there and I'm going to say extract. It extracts it. Then to see it, you got to come here to your project again and refresh it so you can actually see it in Eclipse. And now you see it has the demo folder, but it contains a demo folder, which contains folder 1. So it's nested an extra level deep. So you don't want that. You just want one demo folder, not 2. So if you see 2 demo folders, you can rearrange it to just the one. Don't let that get you. Okay, so back to version 4 here now. I'm going to just close everything off and go to version 4. And version 4 is just like version 3. We're going to change it. So we want to make it so when you enter, like, let's say 50, and you enter 20% tip, and you calculate total, then we end up with 50 plus 20% of 50. Which would be what? 60. So we want to calculate the tip first. We want to make it do something. So let's see how to do that. part of the program should we concentrate our attention on if we want it to actually do something? When do we want it to do something? Yeah.
When you hit the calculate button.
Okay, when the button is clicked. So we want something to happen when the button is clicked. Now, when the button is clicked, what are we going to have to do? Yeah.
Extract the values.
Okay, we're going to have to be able to extract the values from the boxes. The amount of the check and the amount of the tip. And then we're going to have to do something and write and display something in the total box. So you're going to have access to those 3 text fields. And we've got to somehow know when the button is clicked. So let's go find the button. Here's the calculate button right here. And let's see what methods buttons have. And they have quite a few. So this probably isn't the best way to find what you need. It turns out that what we need is something called add action listener. And what add action listener wants is an object of type action listener. And action listener is an interface. So let's go look in the Java documentation and find out how to make an action listener. What is an action listener? So I'll go up here and we'll just do action listener Java. And here's the documentation. And we see that it is, you see right here, public interface action listener. So it's an interface. And it only contains one method, a method called action performed. So given what we talked about, let's try to remember what we learned about interfaces last time. What does it mean that action listener is an interface that contains one method declaration? Not an implementation, it contains a declaration. Yeah?
We need to make a class that uses the interface and actually defines the method.
Okay, that isn't quite the answer I was after. I mean, that maybe be the next question. What is an interface? Important thing to know the answer before you start doing PS10. So let's figure it out. Yeah?
Kind of like a class stub.
Okay, he said it's kind of like a class stub. That's not a bad description. So an interface is just, it has a name like a class, but what it contains is a list of method declarations. In this case, 1. So it's not implemented. And the idea is, if you want to be an action listener, you need to implement the interface. So let me close the loop here. What the button here wants, what calculate wants, is an action listener. You need to give it an action listener object. Yeah?
Is it going to be the object? So this?
Well, we'll see what it is in a second. What do you suppose the button will do with that object when we give it to it? We give it an action listener object. What do you suppose? Yeah?
It'll execute some kind of action.
What's the only thing the button could possibly do with an action listener object? What's the only method action listeners have?
Action performed.
Yeah? Say a little louder.
The one that's in the interface?
Yeah, action performed. The only thing button can do with action listener is call the action perform method. And so what happens is, when the button is clicked, that action listener method is called. The button class calls that method. So if it doesn't have an action listener to call, nothing happens. So we need to give it an action listener object. Now, we don't have an action listener object handy, but it's not too hard to make one. I'm going to turn this tip calculator into an action listener. So I'm saying in my header here, okay, in addition to being a tip calculator, every tip calculator object is also an action listener. So we are saying, okay, tip calculator implements action listener. Why is it underlined in red? Yeah?
You need to import it.
No, well, that may be true. Yep, I need to import it. Okay, now, why is tip calculator underlined in red? Yeah?
Because action listener is an interface that declares a method that we have to define.
Okay. So when we put it up there for everyone to see that a tip calculator is a kind of action listener, it's our responsibility to implement that action perform method. We have to implement action perform, or we're not really an action listener. That's the whole point of an interface, is to pull together some methods and say, if you want to claim to be this interface, implement this interface, you have to implement the methods. So we could go write action perform, but actually if we go here, it'll say the type tip calculator must implement the inherited method action perform. And here's a handy thing that says add unimplemented methods. So let's do that. So it just, somewhere down here, it put the method in for us. So we just have to do something, whatever we want to have happen when the button is clicked, we put there. Well, I'm not quite there yet. Okay, we'll come back to that. All right. What have I got here? Okay, so right here, we have got to add an action listener. We've got to give this button an action listener object to call when the button is clicked. So what object do we have handy now that we can give to it? Yeah?
The action perform method.
Well, the action perform method is not an object, it's a method. We have to give it an object of type action listener.
Tip calculator?
The tip calculator itself. Right? The tip calculator object is an action listener object, because we just said implements action listener. So how do you spell the tip calculator object's name? This. Okay? So we're sitting inside the constructor for tip calculator. So this refers to the object that's being constructed in this case. So we just let this object, the tip calculator object, be the action listener. Yeah?
So what does action listener actually do? Like,
Action listener doesn't do anything. An action listener has a method called action perform.
which isn't defined, right? Or
Well, it's defined. It doesn't do anything down here. The important thing about it, the action listener, is the button now has a reference to it. And whenever the button is clicked, it'll call this method right here. So we just need to make this method do something interesting. Yeah?
But do we need to import action listener to do that, or can we just write our own method to?
Well, why do we have to go, so basically what he's asking, why do we have to do this? Why do we have to say implements action listener? Why not just leave this out and do everything the same? We can still implement action performed, but what's gone wrong now? Why do we have to advertise that we implement the interface? Yeah?
Because tip calculator won't be of type action listener anymore. We can't use
Okay.
that as a
So when we try to pass this, the tip calculator object, to add action listener, it's going to complain and say, I want an action listener, and you didn't give me an action listener. You gave me a tip calculator. So it's not enough to have that method action perform defined. The class itself has to claim to be a tip calculator. So you've got to implement the interface so you can pass yourself as a parameter to the button. Yeah?
But if this action perform method doesn't inherently do anything unless we implement it, why does it matter that we use this
Well,
action method to make the button be pressed?
Okay, if we want to be notified, if we want something to happen when the button is pressed, the only way to have anything happen is to hand the button an action listener object. And then it's up to that object's action perform method will be called now when the button is clicked. And we just got to make it do something interesting. So we just need to put some code in action perform. Yeah?
So instead of this, could you refer to a different class that has an action listener?
Oh yeah. We could have created another class and implemented action listener and passed it in. Anything that implements action listener, we could pass as a listener. In this case, this is the only class I have around, so I just made it the action listener. Yeah?
What would happen if you had multiple buttons that did different things?
What if there were multiple buttons?
That did different things?
You know, we're just sort of scratching the surface of how to do this. You could have a different class serve as the action listener for each button. Or you could have a single action listener that there's a parameter, when action perform is called, you can find out which button was clicked. You could have an if inside the action listener, inside action perform. So right now we just got one button, so let's deal with it. So let's write something here. So let's say JOption pane dot show message dialog. So all semester I've had you using a method in my I gave you a dialogues class that had a show message dialog. No, it doesn't like that. If you're in a real GUI, instead of using my dialogues class, use JOption pane dot show message dialog, or you want to use the methods from the JOption pane class. So what I've done is I've said when action performed is called, it's going to pop up a window that says clicked. So we can see that. So let's run the method. That's good. And let's click the button. Okay? So what happened was the button realized it had been clicked. It went to see if it had an action listener. It did. And so it called the action listener's method, action perform method, which brings up that box. Okay? So now we just got to make that method do something other than pop up the box. But before we do that, let's try something else. So you get a parameter. I'm trying to change that to E, but I'm having a hard time. That parameter action event will tell you something about what happened. So you can, let's try this. Rather than saying clicked, let's do E dot get source. So get source will tell you what was clicked. And then I'll just do toString. Let's see if we can find out what was clicked. We'll run it. And it tells me it was a J button and there's all this stuff inside. So we can tell the button was clicked. That looks pretty complicated. But there are a variety of methods you can use in here to find out stuff about the objects. There's get source, get ID, get modifiers. Set source. I'm surprised I had to. Anyway, I'll say more about that when it matters. Okay, what do we want to do inside of this method? Yeah?
You want to calculate the tip?
We want to calculate the tip. So where are we going to go? How can we go and find, say, the amount of the check? Where is that? Let me run the program again. When the button is clicked, where's that code? Where's our code down here for action perform going to look to find the amount of the check? Yeah?
The check amount text field.
It needs to go find this text field and get the text out of it. Okay, well, let's go find that text field. So up here, I created the controls. There it is, amount. So we want to go to the amount text field and pull the amount out. So let's do this. So amount dot, there must be some way to get stuff out. Uh-oh. It says amount cannot be resolved to a variable. What's the problem? We saw there was a variable called amount, but this method apparently can't access it. What gives? Yeah?
Well, amount isn't a double, it's a text field.
Well, it's right, true, but I can't even name the variable. Yeah?
Do we need a scanner that checks what's in the text field first?
No. Well, we're going to have to do something like, we're going to have to do some parsing. But right now, I can't even, if I try to access that variable, if I just say amount here, it doesn't know what amount is. Yeah?
Would it be this dot amount?
Well, would that be it? Would it be this dot amount? No, still doesn't know what it is. Yeah?
It's because it's defined inside another method.
Right, it's a local variable to the constructor up here. Here's amount. It's a local variable inside the constructor. Of course it can't be accessed. So what are we going to do? We need to make it accessible between the constructor and action performed. Yeah?
Make it private.
Well, yeah, make it, I mean, the right, yeah, what? Make it an instance variable. Yeah. So what we need to do is come up here and do something like this. So what is it? Private is a JText field. I mean, private JText field. So we make it an instance variable. And down here we remove this declaration. So now when we create the text field, we store it in an instance variable, so it'll stay there as long as the text, as long as this tip calculator exists. So that means that down here, we can access that now. Amount is now an instance variable, and it can be accessed. So what we want to do is something like this. Amount dot, let's see, there must be a get method like get text. Get text will give me what was typed to it. That's going to give us a string back. That'll give us a string that's in the box. What do we want to do with that? Right, we want to parse it. Good. So that'll get us that number. And then we can do the J option pane. Wish I hadn't deleted that now. Show message dialog. And we'll give it amount. Turn it to a string so we can display it. And we're parsing it and turning it back to a string. But anyway, now I run it. I enter like 55. I say calculate total, and it read the 55. Yeah?
Well, are we ever going to do anything with the whole thing? Do we have to?
Well, we're getting there. Yeah. Yeah?
Why do you use null in your JOPS and pane show message dialog?
Yeah, so what goes here, you're supposed to give it the component over which you want the box to be displayed. And by passing null, it just puts it in the center of the screen. Yeah?
What if you click the button and type everything into our box?
Okay. So what happens if we run the program and don't type anything in the box? What's going to happen? You know, we get an exception, a number format exception, because it didn't parse. So we'll worry about that in a second. Okay, that's how you get the amount out. How would you get the tip out? How do we get the percentage that we need to, the tip percentage that we need? Let's see, what was that box called? Tip. So we need to do basically the same thing here. We need to go to the tip box. And get its text out and parse it. But of course, that's going to cause a problem. It says tip cannot be resolved. And why? It's a local variable. Now we could do what we did before, but here's a neat little thing. One of the methods says create field tip. So let's try that. Create field tip. So it goes up here, I hope. I don't know where it put it. Yep. It just declared for us something of type tip. Now it made it an abstract button because it didn't know better. So that's not such a good thing. Didn't save much typing. But anyway, we have a field called tip. What else we need to do? Yeah?
You need to define what tip is.
Well, I mean, okay, let's try this out now. Let's run it. And, no, that's not going to help. We come down here. So let's display the tip that we get. So we're going to read the tip, or actually percentage. So let's run this. We'll enter a number here. We'll enter a number here. We'll say calculate total. And boom, we get an exception. A number format exception. Why? Looks like it's good. We read. Yeah?
Because the tip instant variable that you declared is not
Right. Yeah, we declared a tip instance variable, but we never gave it a value. We still have a local variable called tip we're storing the text field in. So let's just make it so that the constructor stores into the instance variable. So now when we run it, 55, 22, calculate total, we get the actual tip. All right, so we got a way to get the tip, we've got a way to get the amount. What do we do now? I'll call it pay. So how much are we supposed to pay now? How do we calculate the amount to pay? This is first lecture stuff, yeah?
Amount times percentage divided by 100.
Well, it'd be amount plus
Oh, yes, sir.
amount times percentage divided by 100. So that's the amount we have to pay. And what is it doing this for? Oh. It's AMNT plus AMNT. Okay, and what do we do with pay? What do we need to do with that number now? And we could, let's just do it this way. We could pop up a box, why not? So let's enter 100, it's easy to test. Let's in 20%. So we expect to see 120 is the amount we have to pay. So it calculated 120 correctly. But I want to put it in this box right here, under total. I don't want it to be in the J option pane. So how do we get it in that box? Yeah?
Do we create a new J label?
Well, we've got a box right here to put the answer in. It's just a matter of what? Good.
You do the label.set text.
Right. We need to go find that box and set its text. There's a set text method. So let's go find it. J text field total. This is the thing that contains the answer. So down here, we want to do something like total dot set text to pay to the string pay. But what's it complaining about? Same thing as always. It's a local variable. We can't access it. So I'm going to try one more way to fix it up. See if we can find a shortcut. Let's go to total here, which is a local variable. And I'll right-click on it, and I will say refactor. And I'm going to say extract local variable, convert local variable to field. That looks good. So I'll say convert local variable to field, and I'll say OK. And it removes the declaration of the local variable and puts it up here as an instance variable. OK, we finally found some shortcut. And then back down here, all is good. We can access total. We don't need this anymore. We run it. We enter 100. We enter 20. And it displays 120. Okay? So let's review what we had to do to make this work. We had to create a method that could access the amount field, the tip field, and the total field. And to make that work, we had to make them instance variables. So some of the things in our GUI are just local, are stored in local variables. But 3 of them here are instance variables, so they can be accessed in the action perform method. And we had to make the tip calculator implement the action listener interface so we could pass it into the button. Now, how can we make it so that doesn't happen? just catch the exception. We know how to catch exceptions. I don't even really care what exception you catch.
You should use the surround with.
Oh, there's a surround with?
Yeah.
All right, Stephen. Since we're looking for shortcuts today, we'll pick that code. We want to put it into a catch block. Let's go to refactor. And
No, surround with, right below
we'll
refactor.
surround with a try-catch block. Very good. And it even knew what exception we can get here, or number format exception. And then, what can we do? Oh, rats, I have to type this again. Just display an error message. Didn't like the letter E there. Okay, let me run it. And let's do this. And it tells us something's wrong. And we can do better with the error message. Yeah?
When you surround with a try catch, it told you, well, I know you're trying to place a double, so you might get a one format exception. Does it just kind of check out what's
Yeah. I think it's looking at the methods and figuring out what exception you can get. Stefan's apparently the expert. Is that what it is?
Yep.
Okay. What if instead of a pop-up, we'd like to display the error message in the window here? What would we have to do? Yeah.
Total.setText.bad.
Well, I want to display it somewhere new. I don't want to.
Oh, okay.
Yeah.
Create a new panel in there and then set into the set visible to true.
Okay. So essentially what we'd have to do is create, let's say, put a J label right below total and have it initially have nothing in it, so it would be invisible. Then to display the error message, you would add the error message text to it. So I bet I can do that in 1 minute. So what do we decide we have to do? We have to create private, let's say J label, error. And then we're going to come down here where we're adding things. Error equals new J label. Good. And then down here we're adding things. After we add total, we're going to say something like control panel dot add error. So we'll add a place for that. Excellent. And then what do we change down here in the action listener? Take this out, and instead we say error dot set text bad. So now when I run it, you don't see any error message here because the label is blank, but it shows up. Now the problem now is it never goes away. So we probably want to change it now so that when you successfully, you click it again and it works, it should clear it. It should clear the label. So it just becomes ever more complicated. Okay? So we'll talk a little bit more about this on Monday, and then your assignment will be due a week from now.